Hello everyone. I hope you have enjoyed my previous videos on the Snowflake knowledge. So here comes the next one, and I'm so excited to share this information with all of you. Here is the architecture. So Snowflake architecture is basically consist of main three layers. So if you see, this is the database storage layer, then comes the query processing layer, and then the service layer. So I will go through each layer step by step so that you guys have a clear understanding of the entire Snowflake architecture. And why we are going through the Snowflake architecture is once you have a better understanding how data is flowing in it, how the architecture is actually maintained, what are virtual warehouses, you will get a very good clarity. And once you use it, you will understand what exactly is happening. So let's start with the database storage. So database storage is the layer where the data is stored, but the data is not actually stored in Snowflake. The data is actually compressed and optimized in a columnar format, which is purely managed by Snowflake. So Snowflake manages the optimization, the compression, the conversion of these rows data into the columnar format, and then compress that into the files. And then eventually the data is actually stored in AWS S3 buckets. So this AWS S3 buckets cloud storage data in a columnar format is not actually visible or accessible to the users. This data we can only access via SQL in Snowflake. So this is the database storage layer of the architecture. Next layer is the query processing layer. So in query processing layer, we have various virtual warehouses. So this virtual warehouses, do not confuse these virtual warehouses with the data warehouses. Data warehouses is a totally different concept, but virtual warehouses in Snowflake is the MPP cluster, which is called massively parallel processing cluster, and which has various number of compute nodes. So in other words, you can understand this as that virtual warehouse is the compute power of a Snowflake, where exactly the query execution happens. That's why this particular layer is called the muscle of the system. Next layer is the service layer. So in the service layer, what happens is lot of management is done here, like infrastructure management, transaction management, security, and the authentication and the access control is also taken care in this particular layer. So next step, what happens here is the query parsing, the query optimization, and the metadata is also stored for various query results, which are actually sent to the data storage and computed by virtual warehouses, and then result is given back via service layer to the user. So I hope you got a good understanding of the Snowflake architecture. So in summary, I'll say it again. It has three layers: database storage, where the data is actually stored in a compressed and columnar format into the files which are sitting at AWS S3, not visible directly to the user, but by SQL from the tables in the databases and schemas. Second one is the query processing, which is done by the virtual warehouses. These are the compute nodes and also called the muscle of the system. Third one is the service layer, where a lot of management happens. This is actually the brain of the system, which manages everything. So let's go further and see some of the concepts of the virtual warehouses. So if you see this diagram, a virtual warehouse is, as I have already informed you guys, it's an MPP cluster. So MPP is massively parallel processing cluster. So in Snowflake, the virtual warehouse size are defined as extra small, small, medium, large, extra large, 2XL, up to 6XL today. they it might increase, but as of today it is 6xl, which is 512. So what is 512, what is 256? Let's see here. So if the virtual warehouse size in Snowflake is xs, it means it has just one server or the one compute node. So this is a cluster with just one node. That's why its size is 1. If it's a small, it's a cluster which has two nodes or two servers or two compute nodes, we can call them. If it is a medium, it is 4, and so on. One more important thing to note here is how the billing is done. So for example, for a medium size virtual warehouse, there are 4 compute nodes in this cluster. So the pricing is like 4 credits per hour. So if this size of virtual warehouse is running for an hour, the Snowflake will charge you 4 credits per hour. And then there is another what you can say rates for the credits, like 1 credit is how many dollars. So that there is a rates available based on the region. Now you got a clear idea that how the pricing is done. We'll go through in more details on the pricing, but if you convert this 4 credits per hour into per second, then it will come as 0.0011 per second. One more important thing to note here is that Snowflake charges by second. So in this example, if it is 4 credits per hour, it will be 0.0011 credits per second. So but it will charge you for the minimum of 1 minute, and then it goes by second. What I meant here, if your Snowflake virtual warehouse is up for 10 seconds and then it goes down, then Snowflake will charge you for 60 seconds because it charges you for a minimum of 1 minute. Another example is if your Snowflake virtual warehouse goes up for say 10 seconds and then goes down and then again run for 70 seconds, then it will charge you for 60 seconds plus 70 seconds, which is 130 seconds. So that's how the Snowflake pricing works at a very high level. We will go into detail once we go through it. Next thing is I wanted to touch base on the multi-clustering part, what exactly it is and how it is used. So as in the previous diagram, I have explained what is a single cluster. So for example, this a cluster is the large virtual warehouse size cluster L has 8 compute nodes. So for example, what is happening in your system, let's take an example that users are processing the queries are going to the database, single cluster is returning the results back to the users, everything is working very nice, sweet and fine. But what happens, say for example at 10 a.m. in the Eastern time, lot of users came to the office, and which increased the concurrency. So if you are on a single cluster node, since we have the same compute power and a lot of users are coming in, they all have to wait because the power is only a single cluster we have. So the queue will keep on increasing. So what Snowflake does internally, it identifies if there are a lot of people waiting in the queue, let me put more clusters or let me span more clusters to address the issue of concurrency. So if there are some multiple users in the queue, the Snowflake will span one more cluster, and then some of the users can go to that one, and then one more, and then some of the users can go to that one. That way it solves the issue of the multiple users. So now you got an idea like how the multi-clustering happening, but how many clusters can a virtual warehouse actually bring up? The answer is in the configuration setting. So there is a maximum number and the minimum number you can choose when you are creating a virtual warehouses. So I think you got a clear idea what exactly is multi-clustering and what are the virtual warehouses. In our next session, we can just really go and create some of the virtual warehouses so that you guys get a clear idea what exactly is virtual warehouse and how can we really configure and see multi-clustering and how can it auto resume and auto suspend. So I think you got a clear idea, and I will see you soon.